Hey everybody, today is going to be about the fundamental theorem of algebra. Mainly we are going to be talking about how we can use zeros to write rules, and then we're going to be talking about the rule of signs and how we can use that to identify all the zeros or how many zeros there are going to be in a function. So first, I just want to do a reminder of how we can calculate the number of solutions or determine how many solutions there are in an equation. So here it says, how many solutions does x cubed plus 5x squared plus 4x plus 20 have? And remember, we just have to look at the degree. So there are 3 solutions because the degree is 3. All right, so that's just a reminder from the last or previous sections. And we're going to use that to our advantage in this section. So in this case, let's see. I want to start off by this first example. It says use zeros to write a polynomial function, and what they're going to do is give you all the zeros. So here we've got the given zeros of -1, 2, and 4. All right, and the key is that it's a leading coefficient of 1, and when it says write a function of least degree, that just means that if there's only 3 zeros, then at the end it should only have an x cubed. If there's 4 zeros, then in the end it should be x to the 4th. All right. So what we're going to do to start this is first recognize that there's going to be 3 factors because there are 3 zeros. All right. So now what we're going to do is basically write it in factored form. And to do that, we're going to take all of our zeros and we're going to write them as the opposite of whatever their sign is. So this is what it would look like. It was a -1 in our equation for our zeros, so it's going to become x plus 1. All right. Then it was a +2, so it becomes x minus 2. And then +4 becomes x minus 4. So this right here is in its factored form. You've got all your variables, and we're multiplying these all together. And now we're just going to start simplifying by using FOIL. So I'm going to multiply the last 2 together first. So when I do that, I get x times x is x squared. X times -4 is -2x. -2 times x is -2x, and then -4 times -2 is +8. All right. Then I'm going to combine like terms, and I get x squared minus 6x plus 8. And then I'm going to FOIL again, or distribute basically. So I'm going to multiply all that out. Remember, you take the first x in the x plus 1 and times it by all 3 in the second equation, and then the 1 times everything. Okay, so that's basically what I've done here is I've multiplied everything all out. And then lastly, I'm just going to combine like terms. So I've got my x cubed, -6x squared, and x squared gets you -5x squared. 8x minus 6x gets you 2x, and then plus 8. So this right here would be our final solution. So this polynomial, when you would draw it later, when we get into the last chapter or last section, it's going to hit the x-axis at -1, 2, 4. All right? So I want you guys to go ahead and try this one. It says, oh, I just realized I gave you the same exact example. So let's go ahead and skip that. Never mind. Let's see. So the next part to this is if you have complex numbers. So if we are given that a 0 is a complex number, in other words, if it's imaginary, so it says if a plus bi is an imaginary 0, then a minus bi also has to be a 0. And the key to remembering this is that imaginary numbers are always going to be traveling in pairs. All right. So if you have the positive one, you have to have the negative one, and it's a 0. And this is going to be really important because that way you have the correct exponent in the end. You don't want to forget it. So let's look at an example using the complex conjugate. So here it says you're going to write an equation where the leading coefficient's 1, and you have zeros of 2 and 1 plus I. All right. Well, it looks like there's only 2 zeros, the 2 and the 1 plus I. But remember, complex numbers have the positive and the negative. So in reality, this function really has 3 zeros, the 2, the 1 plus I, and the 1 minus I. All right, so that's important that you get all of them listed before you start making your equation. Now, this is the part you have to be very careful, and you have to kind of remember back to the first semester with I. When you start to write your function, you're going to have to use parentheses, and you're going to have to be organized with your work. So this is writing everything in its factored form. So my 2 becomes an x minus 2. My 1 plus I just becomes x minus 1 plus I. And then my 1 minus I becomes x minus 1 minus I. And this is the part that's a little bit tricky. notice that here we've got an x minus 1 and we've got an x minus 1. So what I'm going to do is I'm going to regroup my parentheses. Okay, I'm going to move my parentheses around a little bit so that my x minus 1 and my x minus 1 are matching. And the reason I'm doing this is because it's going to make it a lot easier when you have to FOIL everything out, and that way you don't have to do a bunch of ugly trying to like distributing. So in this case, I'm going to start multiplying, and this is what it's going to look like. So what I did is I took my x minus 1 times x minus 1. Well, that's two of them, so that's x minus 1 squared. All right. Then I'm going to take x minus 1 times I and negative 1 times x minus 1. Well, what happens is that those cancel out. And then lastly, I take negative I times I, and that gets me negative I squared. And then you have to remember the rule that I squared is always the same as negative 1. So I just plugged in a negative 1 here, and I FOILed out this x minus 2. If you remember the shortcut for FOILing from earlier sections, that's great. If not, you might have to do it off to the side a little bit. So this is me just simplifying. All right, and then I'm just going to start combining like terms in the far right parentheses. So you get x minus 2 equals, or times x squared minus 2x plus 2. So there are no longer any i's in your problem, which is what you want. So if you end up with an I in your answer, then you have to go back and fix it. And then, of course, lastly, we're going to distribute again. You guys should know how to do this by now. And then we combine like terms. So we get x cubed minus 4x squared plus 6x minus 4. Right? So if you have any questions about steps 2 and 3, please make sure you ask before you go too much farther, because I want you guys to be comfortable with it, especially if you didn't deal with I's very much at the end of the semester because you were behind. You want to make sure you ask for help on those problems. The same thing works for irrational conjugates. So an irrational number is just going to have something that's going to square root. All right, so if you have a plus the square root of something, then you have to have a minus the square root of something. So just like complex numbers travel in pairs, so do irrational numbers. So let's look at an example. The example with these are going to be very similar. So here it says coefficient has to be 1, and 3 and 2 plus root 5 are zeros. So that means that 2 plus root 5 is a 0 and 2 minus root 5 is a 0. So in reality, we're going to have 3, so our exponent in the end, our degree, is going to be something cubed. So I went ahead and I filled in my factored form, so x minus 3, x minus 2 plus root 5, and x minus 2 minus root 5. Just like the imaginary numbers, I regrouped the first two so that they match, x minus 2 and x minus 2. Okay, and then I'm going to start to FOIL. So I am going to multiply, and I get x minus 2 squared minus 5 in the far right, and then x minus 3 over here. Then I expand my squared part, so I get x squared minus 4x plus 4. Then I combine like terms. And then lastly, I'm going to multiply. And you guys, like I said, you guys can do this. If you have trouble with steps 2 and 3, please ask. So this is what I get when I FOIL everything out. And lastly, of course, we combine like terms. And remember, we don't want any square roots in our answer for this one because the square root of 5 times square root of 5 is just 5. So it gets rid of those ugly square roots and we're just left with nice numbers. And it was a degree of 3 because we had the three zeros at the beginning. So we get x cubed minus 7x squared plus 11x plus 3. Alrighty, I'm going to skip this one. Sorry, guys. Okay, now the rule of signs, this is hopefully going to help you determine if you're going to have positive answers, negative answers, or imaginary answers in terms of your zeros. And the whole goal is that they found a relationship between the coefficients of polynomials and the number of zeros and the types of zeros that they had. And this was obviously figured out a long, long time ago. So the rules are going to make more sense once we get to an example, but I want you to write this down. It says that the number of positive real zeros, so positive answers, is equal to the number of changes in the signs of the coefficients, or is less than this by an even number. Okay, so say in an equation the signs change 4 times. Then that means it could be You could have 4 positive answers, you could have 2 positive answers, or you could have 0 positive answers. It's going to be even, it's going to count down by an even number, all right? The same thing applies for the negative ones. So it's going to be the number of negative real zeros is the number of changes in the signs of the coefficients or less by an even number. And I'll explain the difference between these two here in a second when we get our example. So here's example 1. We've got this x to the 6th minus 2x to the 5th all the way down to -8. And it says determine the possible numbers of positive zeros, negative zeros, and imaginary zeros for this equation. So what we're going to do is we're going to start by checking how many times the signs change. So it changes from positive to negative right there. Then it changes from negative to positive. Then positive to negative again. And that's the only time it changes, okay, because the rest of them are all negatives. So in this case, it says there are 3 sign changes, so that means that we either have 3 positive real zeros or we have 1 positive real zero. We count down by 2s, all right? So we counted 3 changes, so we could have 3 positives or we could have 1 positive. We're going to do the same concept for the negative equation, except this time we're going to, wherever you see an x, you're going to plug in a negative x, all right? And the reason you do this is so you can look at all the negative changes. So this time I plugged in, wherever I saw an x, I plugged in negative x. And then you have to simplify. And what this might do is it might change some of the signs. Well, anything to an even power is going to become positive. Anything to an odd power will change the sign. So negative x to the 6th is going to stay x to the 6th. Negative x to the 5th becomes negative, which makes this negative to a positive, and so forth. So we're just changing the signs, all right? So this becomes x to the 6th, 2x to the 5th, 3x to the 4th, 10x third, and then negative, positive, negative. So notice that my signs have changed from the original because I included a negative with my x. So now we're going to see when the signs change for this one. So it changes from the 10x cubed to the negative 6x cubed. Then it changes from here to here and here to here. So this time it changes 3 times. And what this means is that it's going to be a possibility of 3 negative zeros, okay, or 1 negative zero. So just like before, we take our number and we subtract it by 2. That's going to give us our other possibility. So now from here, what we're going to do is to make a table. And this table is going to look like this, okay? So you're going to have a positive column, a negative column, an imaginary column, and then the total possible values. Remember, we get the total by the highest degree, which was a 6. So we're just going to list all the possible combinations. So we have the 3 positive zeros that we could have had. We have the 3 negative zeros that we could have had. And notice that this totals 6, so that means that there can be no imaginary ones, all right? But then if we have 3 positive ones but only 1 negative one, because that was a possibility, that gives us 4, which means we have 2 left over for the imaginary. Okay? And then if we go to the positives where we only had 1 positive but 3 negatives, that gives us 4, which leaves us 2 possible imaginary. Okay? And then lastly, we have 1 positive and 1 negative. That's only 2. So that leaves us 4 imaginary zeros to get the total of 6. So you need to make sure that all of these rows add up to your total column. Okay? And that's all you got to do. So it's all about signs. So I want you to go ahead and try this example where we have this. It's a lot smaller equation. We've got x cubed plus 2x minus 11. So pause the video and then check your answer. All right. So in x cubed plus 2x minus 11, we're first going to check the signs. So it changes only once from 2x to negative 11. So that means that there's only 1 possible positive real zero. All right, and if you subtract 2, you get negatives, so only that doesn't work. So in this case, only 1 positive real zero. If we plug in negative x's, negative x to the 3rd is going to be negative x, and 2 times negative x is going to be negative 2x. So in this case, we have negative x cubed, negative 2x, negative 11. Well, now, if we look at that, that didn't change signs at all, which means that there are no negative answers. Okay, so in our table, we'd have a 1 positive real zero. We can't have any negative zeros, which leaves us 2 imaginary possibilities for our total of 3 because the degree was 3. So this is our only solution in this table because we don't have any other possibilities for positives or negatives. So we're done. All right, I'd like you to go ahead and try this one on your own, see how you do. If you have any questions about plugging in the negative x for the odd or for the negative answers, let me know, but see how you do with this one. All right, so hopefully you saw that your changes, it goes 1, 2, 3, and 4. So that's 4 possibilities, 2 possibilities, or 0 possibilities. So this is going to have a little bit bigger of a table. All right, and then when we plug in the negative x's, we reduce it to 2x to the 4th, 8x, 6x squared, and 1. And notice that doesn't change at all. It's all positives, so there are no negative answers. So we're going to have 3 rows, 4, 0, 0, because our total is 4. We could have 2 positives, which leaves us 2 imaginary. Or we could have no positives and no negatives, which means all the answers would be imaginary, and we'd be done. So the reason we do this is to see how many types of answers you should have in the end. So you could do this real quick for a problem and say, okay, I know I'm going to have potentially two positive answers and 2 imaginary answers. And then if you know you're not supposed to have any negatives and you end up getting a negative, you know that you've got something wrong. So it's useful just in checking your work, identifying the positives or the potential solutions, and even if you're going to graph, knowing potentially how many types of answers you're going to have. All right, so that's it for this notes. If you have any questions, please let me know, because this section can get a little complicated, and so I want you guys to be pretty comfortable by making sure you're getting some help when you need it. Thanks for listening.